Hello and welcome back to another episode of Math with Sohn. Today we're going to be doing the distance formula, but I'm going to be doing it with the Pythagorean theorem to kind of help make it more make sense, because that formula sometimes is crazy. Okay, so you could use the distance formula, but I like to just go and use the slope, the unsimplified slope, especially if it is graphed. So going from left to right, how much did we go down? We went down from 5 to negative 2. So we went down by, I think, 7. So we got 7 here. And I wrote negative 7, but you can write positive 7. It'll work out. I encourage you to actually write positive 7 in the distance formula aspect. And then we went over by 1, 2, 3, 4, 5, 6. So we went over by 6. And for those of you that are unaware of the Pythagorean theorem, it is a squared plus b squared equals c squared. Guess what your a and your b are? Here they are. And they're interchangeable. So if you choose to use negative 7, make sure you put it in parentheses. If you use positive 7, it won't matter. All right? So we get 49 plus 36 is equal to c squared. If you add 49 and 36, you get 85. And the square root of 85 is 9.21. You may want to keep it in square root form. You might want to keep it in a different thing. It says round to the nearest tenth, so that would be 9.2. All right, so that is the Pythagorean theorem method, which works anytime it is graphed. You can always just count. Like, look here on number 3. We're going down by 1, over by 2. So our slope is negative 1 over 2. If you even write that, that is your A and your B for your Pythagorean theorem. So that'd be 1 squared plus 2 squared would equal c squared. If you do negative 1, which you can avoid it without writing it, but if you do negative 1, you need to put it in parentheses. So 1 squared is 1, 2 squared is 4. We got to take the square root of 5 because you got a square root to get rid of that c. The square root of 5, ladies and gentlemen, is 2.23. Would be the length of these two things. So that would be the distance. I've been calling it c, but they're technically units. All right. Now, what if you don't have a triangle? Like here on number 4. Oh my gosh, you don't have a triangle. Well, we're just going 1, 2, 3, 4, 5, 6 up. We just went 6 up or 6 down. So the distance between those 2 points, ladies and gentlemen, is 6 units. That's it. That's all she wrote. That's all you got to do there. All right. Now, what happens if you have 2 points? If you have 2 points, we're going to do this 2 different ways. We're going to do it with the Pythagorean theorem, the way I have been showing you. But you should know that the distance formula is equal to your change in y's, y2 minus y1 squared, plus your change in x's, x2 minus x1 squared. And you may think, well, wait a minute, that's not the distance formula that I remember or know. If you square root to get that, you get your distance as the square root of the y2 minus y1 squared and the x2 minus x1 squared. So it is the same formula, but I like this one because it shows a squared plus b squared is equal to distance or c squared. All right, so it's the exact same formula. Now, I'm going to show you the slope method, and then I'm just going to show you what to do if you have to type it into the distance formula, which I don't particularly enjoy as much as the Pythagorean theorem. So let's find our slope. Remember, our slope is y2 minus y1 over x2 minus x1, and that will end up being our a and our b for our Pythagorean theorem. So we have x1, y1, x2, y2. We got negative 7 minus 3. And we have another negative 7 for x2, minus x1, which would be minus negative 2, which ends up being a plus a positive 2. You end up with negative 10 over negative 5. Do not simplify. If you're using the a squared b squared method, do not simplify it. You have your a as 10. You got your b as 5. Then it equals your c squared or your distance squared. You end up with 100 and then 25, which is 125 is equal to c squared. Then you can square root the 125, and that would be your c. If you want the decimal place, that is 11.1 for the distance between those 2 points. Okay? Now, maybe you don't like that. Maybe you prefer to just use the distance formula right away. Well, we could do that too. All right? If you do y2 minus y1, you end up with negative 7 minus 3. Does that look familiar? Negative 7 minus 3 plus x2 minus x1 would be negative 7 minus negative 2 squared. And if you have a nice calculator, you can type this whole thing in with the parentheses and the negatives, and it will spit out the answer of 11.1 as well. It might also spit out 5 square root of 5, which is like the simplified radical version if you have a special calculator. And if you do have that special calculator, you probably want to hit the SD button. That turns it from 5 square root of 5 to 11.1. Okay? Let's do another one of these. I'm out of room on this paper. Let's do number 19. For 19, we have 0, negative 2. And we have 5, negative 5 and 1. There's your x1, y1, x2, y2. I am going to start with the slope formula because that's what I prefer. Negative 1 minus negative 2 over negative 5 minus 0 ends up being negative 1 minus negative 2 ends up being a positive 2 plus a positive. So we have 1 over negative 5. There's your A, there's your B. Let's do the Pythagorean theorem. 1 squared plus negative 5 squared. If you do put it in negative, you have to put it in parentheses. Otherwise, know that negative 5 times negative 5 is the exact same thing as positive 5 times positive 5. 1 plus 25 equals c squared. We get 26 is equal to c squared. The square root of 26 would give us our c, and the square root of 26 is 5.1. It's actually 5.09. All right? Okay, now we got an interesting one. 25, this is a bonus problem, okay? This is for the people that are ready to take their level of math to the next level. So we got square root of 2 away from this point right here. So we got to think. We know that the distance is going to be square root of 2 away. We also know that the distance squared is equal to your change in x's and your change in y's. Now I got a issue with this one because there's more than one right answer. There's actually an infinite amount of correct answers. We just need one of them to work though. We do know that this is the point right here, negative 1 and 5. So let's plug that in for x1, or we'll plug it in for x2 and y2. All right? By the way, if you've learned about circles, this is the equation for a circle as well. So we got square root of 2 away. That is our distance squared. We got x2, which is negative 1 minus x1 squared. We got y2, which is 5 minus y1 squared. Now remember how I told you that there are infinite amount of answers to this. That is 100% true, that any numerous amount of points should allow this to happen. So with that being said, I am going to try something radical here. I am going to try plugging in a 0 for x, just because I think that might help. All right. First off, I'm going to take the square root of 2 and square it, and if you square root 2 and then you square that, you get 2. I'm going to plug in a 0 for x because, again, there's an infinite amount of answers, so why not make my life easier? I cannot plug in a 0 for y, though, because I still don't know a y value that would make it work. So currently, all I know is that I'm trying to get x to be 0. Okay? And with that being said, it might work, it might not. Maybe 0 is just too far away. There's a chance, but maybe it's too far away. So let's see if this is solvable with the 0 plugged in. If it's not, then we're going to have to graph it and go back to the drawing board. Again, bonus problem. Let's solve for y here. Let's see what happens. Negative 1 squared is 1. So if we have 1 here, we'd have 2 equals 1 plus that 5 minus 1y squared. We're going to subtract 1 over. We're going to solve for y1. So we get 1 equals 5 minus negative 1y squared. Well, how do we get rid of a squared? Yes, square root. And what is the square root of 1? 1. equals 5 minus y1. We're getting so close to the answer, we have to subtract 5 from both sides. If we subtract 5 from both sides, we end up with negative 4 is equal to negative 1y, which means a regular y would equal positive 4. And that is a singular point that would be square root of 2 away from negative 1 comma 5. Let's see if it even looks like it is. Here's negative 1 up by 5, dot, and 0, 4 is right here. Does it look like these two are about 1.4 away, which is the square root of 2? And the answer is absolutely they do. All right, that's going to do it for this one. Until next time, everybody, stay positive, my friends, and I will see y'all later. Bye.